Today we're going to be looking at the unit circle. The actual math portion of today is extremely and superbly short. Look at your paper, you're done, everything's there for you. But I'm going to talk about it for a while because I'm interested in the actual math portion of this and the history behind it. Now, I'm not a history person, don't normally care anything about it, but I am very much a math person and I enjoy this, so let's look at it. Alright. For the unit circle, and what you have used all the way up until now, except for a little bit in Math 3, has been in degrees. So you had 0 up to 360 degrees for the entirety of a circle. Now I'm going to tell you something that you don't know. It's not technically true. There is not 360 degrees in a circle. Degrees, by definition, is an arbitrary separation of a turn. Now, what that means is, between the angle here, from my 0 degrees up to 30 degrees, I can draw 30-degree units. Okay? It's a set amount of separation. The issue is, there's an infinite amount of separations in a circle. Okay? A line is made by an infinite amount of points. Same kind of idea here. Now, we're going to start talking about radians, and that's what we're going to use almost exclusively for, well, pretty much eternity, I reckon. So here's what radians comes from. Radians come from something known as pi, and you should be very familiar with it at this point. Pi has been around for several thousand years. About 40,000 to be precise. For these thousands of years, I'm going to show you a little bit of the evolution of pi. You see, mathematicians knew that there was something you could get whenever you take the circumference, when dealing with the circumference of a circle. Okay? Now, whenever the Babylonians made it the area of a circle, they did 3 times the square of its radius. So pi was 3 to them. And the tablets that they wrote on, the indications, they made it close to 3.1. Okay? Well, this wasn't good enough. This pi wasn't, just like I said, an approximate value. They had no reason for using it except for the fact that it worked. So they knew circumference has something to do with pi. Now, the first time pi was actually found to be a steady amount, let's put it that way, not just a guess, was in the year approximately 287 before Christ, and it was made by a man called Archimedes of Syracuse. Well, I'm going to try one more time. Of Syracuse. Yep, not happening. Syracuse. There we go. And here's what he found. And the backstory is he uses polygons to find it. But he found that if you had pi, and you multiplied pi with 2 times 2 radiuses, 2 radii, therefore a diameter, okay, that you would get the circumference. Therefore, he figured out if you divide by that, so circumference over 2 radiuses, radii, or in other words, circumference over diameter, you would get pi, okay? Now, what Archimedes ended up doing was showing that pi was somewhere between 3 and a 7th and 3 and 10 over 71, which was a whole lot more decimals than what had been previously. Okay? That's the part I want to talk about for a little bit. Archimedes found this relationship, though. Circumference is equal, or pi is equal to circumference divided by the diameter. What radians is, it is going to base the length of your arc, so the circumference, in terms of your radius being 1, a unit radius. So if my radius is 1, what I'm really going to have is the circumference over a single radius is equal to 2 pi's. Therefore, when we do a unit circle in radians, you start at 0 and you go to 2 pi. Why is this different? Why is this different from saying 360 degrees is not correct? The reason is pi is an irrational number. Radians is a natural unit for the geometry of a circle, whereas degrees are a separation of numbers. In other words, if I'm going to put it in what I'm going to call a hippie way, radians just flow, man. Alright, now here's what I want to show you, and here's how I want you to remember this so that you can find the radians regardless if I give it to you or not, and you don't have to rely on a piece of paper to tell you what they are. If you know it goes from 0 to 2 pi, if you go halfway, you're just going to have a singular pi. If you take half of that, you're going to have pi over 2. And if you go to the other half, so the 270 degrees, you're going to have 3 pi halves. So I'm going to go up by pi halves every quarter. Okay? Alright. Now instead of doing this, cutting it in quarters, let's cut it in eighths. So halfway between pi halves and 0 is going to be pi over 4. 2 pi over 4, so pi over 2. 3 pi over 4. 4 pi over 4 pi. 5 pi over 4. 6 pi over 4, or 3 pi over 2. 7 pi over 4. And then 8 pi over 4, or 2 pi. Went all the way back around again. Here's the last one. Instead of going by fourths, we're going to go up by quarters. Starting at pi over 6. You get a 2 pi over 6. So pi over 3. 3 pi over 6. 4 pi over 6, or 2 pi over 3. 5 pi over 6. 6 pi over 6, so pi. 7 pi over 6. 8 pi over 6, or excuse me, 4 pi over 3. 9 pi over 6, or 3 pi halves. 10 pi over 6, or 5 pi over 3. And lastly, 11 pi over 6. Okay? Those are the radian conversions for your degree measurements. That's how you can divide the unit circle. Here is the last thing you have to know to be able to do these problems. And you have to remember this. It is 1, 2, 3. 1, 2, 3, 1, 2, 3. Let me show you what I mean. My coordinates on a unit circle, I'm going to put 1. Leave a line for division. 2, line for division. 3, leave a line for the division. And now 1, 2, 3 again. 1, 2, 3. Now the easy part to remember, that's the hard part to remember. The easy part, you divide everything by 2, and you put a square root on everything. However, the square root of 1 is 1, so you do not have to put it on the 1. So put 2's under everything, and square root the numerator of everything. Alright, there you go. Likewise for the rest of them. 1, 2, 3. 1, 2, 3. Radicals and 2's. Now here's the next part I want you to think about. This is on the left. If I was to split this on the xy axis, this is on the left side of the y, so my x values are negative. Okay? And you can do the rest for the other two. I believe in you. You're pre-cal students. There they are. All right, that is absolutely all we're doing for the lesson portion. You have some stuff to work on. Let me know if you have any questions, and I hope you have a great rest of your day.